fair to you guys, because I did promise you questions from 4 to 6, chapters 4 to 6. Okay, where's this thing not sharing?
Question, the test was on chapter 7 questions.
Well, that too, but I can, I can basically ignore the responses for those answers, and don't take that into account for your total grade. So that's not the issue. Well, that is an issue, but not as big an issue as the fact that you were not given any questions at all at chapter 4. All right. So what I decided to do is provide some questions for you to do at home based on chapters 4. Okay, what am I doing? Okay, let me do this. Let me just show you where those questions are located, and then what you can do is complete it. I think I gave the deadline as October 30, which would be Thursday. So if you go to this folder labeled test, right, then you're going to see this here, this link, which will be the additional questions to chapter 2, right? So make sure you complete that, and then upload it into Canvas. I've created a Dropbox for that already, so you can upload it into Canvas. It's not anything major really, in terms of how much time required for you to do it. So make sure you upload it. And what I'll do is I'll attach that to your test, and then your grade for that test will be based on that collected. All right. So I apologize for that, but that's what happens. I never seem to learn this lesson about rushing to do stuff, but that's what happens when you rush stuff and to forget to do certain things that you're supposed to do. And I'll try to do better next time. All right. Okay, so today we'll be discussing chapter 9, which basically deals with stoichiometry. And stoichiometry is a very important area in chemistry. It's basically that area in chemistry which deals with the quantitative relationships between different substances that to play when it comes to stoichiometry. So I'm talking about things like the mole concept. I'm talking about things like balancing equation, which is, I would say, probably the most important step in solving any stoichiometry problem. You cannot solve a problem dealing with stoichiometry if you're not starting from a balanced equation. And what you'll find, especially in the assignment questions I'm about to give you, is that some of the equations that you'll be given, based on which the problems is given, are not balanced. And therefore, what you have to do is balance those equations first before you actually get into the calculations. So what I'm going to do is basically look at a couple of examples, which you should have followed already in the videos provided. So I'm just going to go through this. Hold on, somebody just said something. Oh, okay. I'm just seeing your message, Ms. Westcott, that you're here. Okay, good. And I think I have you down. Okay, so let's see here. This is the PowerPoint from which the video was created. And I'm going to skip because the first part is basically a reminder of the different stuff you should have learned in the previous chapter. So let me talk about this particular slide right here. So here we have a balanced equation. And basically the way we can interpret this equation in a couple of ways, we can look at this at a molecular level and say, okay, one molecule of nitrogen will react with 3 molecules of hydrogen to form 2 molecules of ammonia, all right? But you can also look at it at the molar level. In other words, you could say 1 mole of nitrogen reacts with 3 moles of hydrogen to form 2 moles of ammonia, right? And based on those relationships, you can do subsequent calculations or calculations before use of this equation. And that's what we're going to get into later on. Let me talk about this. So basically, based on this equation here, you can establish a conversion factor which represents the mole ratio between any 2 of the substances involved in the equation. So for example, in this case, because of the coefficient of 3 for the hydrogen here and the coefficient of 2 for the ammonia here, we can write down this conversion factor which represents the mole ratio between the hydrogen and the ammonia. So there we have 3 moles of hydrogen as the numerator in this case, and 2 moles of ammonia as a denominator. So this represents the ratio between this and this. You can also write down the reverse or the inverse of this fraction here. In other words, you can have 2 moles of ammonia above, 3 moles of hydrogen below. which you're going to use is dependent on the type of problem you're going to solve, as you're going to see shortly, right? So this is just highlighting the mole ratio expressed as a conversion factor between the hydrogen and ammonia, right? Okay, let me skip all this here and get directly into, let me see what this is at here. Okay, that's just a molar mass calculation. Okay, so let's look at this example right here. So this question says, in the following reaction, how many moles of lead to chloride is formed if 5.00 moles of sodium chloride react, right? And they gave you the balance equation. Like I said before, in some problems like the one that I'm about to give you, you might not be given a balance equation. But in this case, they did some of the work for us so that we don't have to worry about balancing the equation, right? So what I would do in order to answer this question is I would start off with the moles of sodium chloride given. So the moles of sodium chloride given is 5.000 moles of NaCl, all right? And then, since I want to find out the moles of lead to chloride, that's what the question is asking for here, I would look at the mole ratio between the sodium chloride and the lead to chloride, right? And as you can see, it's a 2-to-1 ratio, 2 moles of sodium chloride for every 1 mole of lead to chloride. So the question is, how do we express that here in the conversion factor? And the answer is, because we're trying to find the moles of lead to chloride, I would put 1 mole of PbCl2 above as the numerator, and I would put 2 moles of NaCl below as the denominator. And then I'll work that out. So simple calculation here. Firstly, this will cancel out with that. So your final answer is going to be 2.500 moles of lead to chloride, and that would be the answer. All right. So that's a relatively simple example, which is the case whenever you're doing a mole-to-mole calculation. Mole of one substance given, and you're trying to find the mole of the other substance according to the question. And again, I can't underscore and emphasize this enough. You have to start off with a balanced equation. Make sure that the equation is balanced. Even if the equation is suggested to be balanced, before you start doing anything else, make sure that you're working with a balanced equation. All right? Okay, any question about this? I don't think there are many questions that could be asked about this, but any questions about this? All right, so let's see if I can find a next example. Okay, here's another one. They gave us this equation here. And again, it's a mole-to-mole question because the question says, calculate the moles of phosphoric acid formed by the reaction of 10.0 moles of sulfuric acid. Again, fortunately for us, they gave us the balance equation, right? So again, I would start off with what we're given. We're given 10.0 moles of H2SO4. Start off with that here. And then the question is, what do we multiply this by in order to convert it from moles of sulfuric acid to moles of phosphoric acid, right? So again, we go to the equation. We look at the sulfuric acid, the phosphoric acid here, the sulfuric acid here. And as you can see, it's a 5-to-3 mole ratio between the sulfuric acid and the phosphoric acid. So the way we represent this here is that because we want to get rid of the moles of sulfuric acid here in our calculation, down here, we're going to put 5 moles of H2SO4. And upstairs, we're going to put 3 moles of H3PO4. And then we do the number crunching. And I can see here that 10 divided by 5 is 2. 2 times 3 is 6. So therefore, the answer is going to be 6.00 moles of H3PO4. Again, this is another relatively simple example. All right. Okay, any questions about this one? Any questions? Questions? Any questions out there in Zoom? You guys feel free to respond, chip in, ask questions, whatever. All right. Okay, so next. Okay, now here we're going to step up the level of difficulty a bit because the 2 previous examples that we have looked at, we were given the moles of one substance and you're asked to calculate the moles of another substance. In this example, let me see if I can find it. You're given same equation as the last question, but this time you're given a mass of phosphoric acid and you're asked to find the moles of sulfuric acid. So you're given the mass of one substance and you're asked to find the moles of the other substance involved in the equation, right? So basically, in this question, you're given 784 grams of H3PO4, and you're asked to determine the moles of H2SO4, right? So in this particular case, what we have to do first, and I'm going to draw like a flow chart here, you have to start with the grams of the phosphoric acid, and then you convert that grams to moles of phosphoric acid, right? And in order for us to do that, we need the molar mass of the phosphoric acid, right? The reason why we need to get the moles is because, again, based on what is given here and here, the coefficients of the two substances involved are related by moles, right? So you cannot just go from grams of one substance directly to the moles of the other substance. What you have to do is convert the grams of the phosphoric acid to moles, and then you do the calculation, or you multiply by the conversion factor, which allows you to calculate the moles of sulfuric acid from the moles of phosphoric acid, right? So basically what this indicates is that you're going to need a series of two conversion factors in order to get from the grams of phosphoric acid to the moles of phosphoric acid. So let's do the actual setup, where we start off with the 784 grams of the phosphoric acid. And then to convert it to moles, we need to engage the molar mass. So up here, we're going to put 1 mole of H3PO4. And down here, we need a molar mass of phosphoric acid. Now, I'm quite sure you know me by now. I'm a bit lazy. So what I'm going to do is go to my trusty old molar mass calculator. Let me do this here. Molar mass calculator. Now what I'm going to do is enter the formula for phosphoric acid, which is H3PO4, and calculate, and according to this here, it's 98.00 grams. So I'm going to go here, and I'm going to put down here 98.00 grams. I hate reading. So by so doing, somebody's trying to say something. Okay, so somebody's asking, what is it you said you were trying to find again while starting this equation again? Okay, I'm not sure what equation are you referring to, Miss Jones? If possible, could you elaborate? Oh, I didn't see your comment. Oh, never mind. Okay. Well, if you say never mind, I won't mind. All right. So as I was saying, we do this in order to convert, as I said before, from grams to moles. So basically, this unit here will cancel out with this unit. So up to this point, we would have determined the moles of phosphoric acid. But remember now, we need to take another step where we multiply by another conversion factor, which allows us to convert from moles of phosphoric acid to moles of sulfuric acid. And that's where the coefficients for the different substances in the balance equation will come into play. It's a 5-to-3 mole ratio. So therefore, I'll put 3 moles of sulfuric acid. 3 moles of phosphoric acid down here as a denominator, and up here I'm going to put 5 moles of H2SO4 above. And of course, what's going to result is that this will cancel out with that, and then we have to do the calculations. So 784 divided by 98.00 times 5 divided by 3, and according to my calculation, I got, now in this case we have to round off to 3 sig figs, so please correct me if I'm wrong, of course, but I got 13.3 moles of H2SO4. Let me do this again, just to make sure. 784 divided by 98 times 5 divided by 3. Okay, so that's what I got, 13.3 moles of sulfuric acid. All right, so that's basically how you do a problem of this type, where you're going from the moles of one substance, you're going from the grams of one substance to the moles of another substance. And if you understand this, then you should also be able to do the reverse. In other words, if you're given the moles of one substance, and then you're asked to find the grams of another substance. In fact, I think the next problem or the next example is of that type. But before I move on from here, any questions about this one? Any questions? Any questions? Okay, so let's move on. All right. Okay, so in this example, it's the reverse, different equation, but this time you're given the moles of one substance and you're asked to find the grams of another substance. And again, they gave us the balance equation. So, any ideas? Let me hear what you guys have to say about this one. How would you start off solving this problem? They gave you 12.0 moles of ammonia, and they ask you to determine the grams of hydrogen. All right, so we're going to start off with 12.0 moles of ammonia. So my question to you is, what would be the first conversion factor that you're going to need to multiply that by in order to start solving this problem? In other words, what would go top here as the numerator and what would go down here as the denominator?
We would put the molar weight, well, the molar weight in the denominator and
Hold on,
one
you put it-
mole in the numerator.
I'm sorry, repeat that. You kind of sound muffled.
Sorry, I don't want to come off too loud, but you would put 1 mole in the numerator.
Sure about that? Remember the numerator is at top. And you want to cancel this unit here. So you sure you want to put the 1 mole above?
No.
So you put it below.
Yep.
1 mole of ammonia below, right? And the molar mass of ammonia would go up top. And then you have to, I can't calculate that easy. That's 3 times 1.008 plus 14.01. So that would be 17.03 grams per mole. So 17.03 grams of ammonia, right? So that's the reason why I put this 1 mole down here, because you wanted to cancel out that mole unit there. Okay, so what you have determined so far is the grams of ammonia up to this point. But remember now, the question is asking for the grams of hydrogen. So that means you need to multiply by another conversion factor. So again, I asked the same question as before. What would be in this conversion factor? What would go up top here as the numerator and what would go below here as the denominator? Oh, wait a minute. I made one big mistake. I must apologize for that. First, we have to do a mole-to-mole calculation first, based on the moles of ammonia, which is here, and the moles of hydrogen, which is here, all right? So in actual fact, you're gonna have 2 moles of ammonia here, and 3 moles of hydrogen here, all right? So that's how we get the moles of hydrogen. So that's a big mistake on my part, so I'm correcting it now. This should be 3 moles of hydrogen above, 2 moles of ammonia below. This could cancel with this. So up to this point, you'd have calculated the moles of hydrogen. So now we get to the next step. The next step is where we convert from moles of hydrogen to grams of hydrogen. So that means that we need a molar mass here, expressed as a conversion factor. Because we have the mole unit down here, this will be 1 mole of hydrogen below. And up top, we're going to have the molar mass of hydrogen, which is 2.016 grams of hydrogen. That's 2 times 1.008. And then, of course, this will cancel out with that. And then that will give us the answer that the question is asking for. So that's 12 times 3 divided by 2 times 2.016. And according to my calculation, this works out to be equal to 36.3 grams of hydrogen. Again, let me make sure that this is correct. 2 times 3 divided by 2 times 2.016. Okay, so that's what I got. 36.3 grams of hydrogen would be the grams of hydrogen required to form that much moles of ammonia, all right? Okay, any question about this example? Any questions? All right, now we're gonna step up the level of difficulty a bit because the examples that we have looked at is where we went from moles to mass or mass to moles, right? In this case now, we're gonna go from mass to mass. So let me just go straight to the example. Dealing with that, again, the same ammonia production equation. This time they gave you 112 grams of hydrogen and you're asked to determine the grams of ammonia, right? So in this case here, you cannot use the coefficients here to establish the gram ratio between the two, because remember the coefficients does not represent the gram ratio, it represents the mole ratio, or it will give you the mole ratio instead of the gram ratio. So in this particular case, what you'd have to do first is convert the mass in grams of hydrogen from grams to moles of hydrogen. And then using the coefficients, you can go from moles of hydrogen to moles of ammonia. And then using the molar mass of ammonia, you can go from moles of ammonia to grams of ammonia. All right. So start off with 112 grams of hydrogen. So to get from grams of hydrogen to molar mass, to moles of hydrogen, we need a molar mass of hydrogen, which we can express here as 1 mole of hydrogen divided by 2.016 grams of hydrogen. So that this cancels with that, right? So we've accomplished the first step where we convert from grams to moles. The next step is where we convert from moles of hydrogen to moles of ammonia. And that's where the coefficients of those two substances in the balance equation comes in, right? So the way we represent that here in this conversion factor is that we're going to have 2 moles of ammonia above as the numerator and 3 moles of hydrogen below as the denominator. So this will go with that, all right? So that's how we get to the moles of ammonia at this stage right here. Then we have to do one last step where we convert moles of ammonia to grams of ammonia. And again, that's where the molar mass will come in. This time we're going to put 1 mole of ammonia down here as the numerator, the denominator. And up here, the molar mass, which will be, I calculated earlier, 17.03 grams of ammonia. So that this will cancel out with that, right? And then we do the number crunching. 112 divided by 2.016 times 2 divided by 3 times 17.03. And according to my calculation, the answer is 631 grams of NH3. So let me do this again, just to be sure. 0.016 times 2 divided by 3 times 17.03. Okay, so that's what I got. 631 grams of ammonia. All right. So as you can see, what we have dealt with so far is basically problems of increasing levels of difficulty. In the first case, we dealt with mole to mole, right? That was just a one-step thing, right? In the next case, we dealt with mole to grams or grams to moles. That's basically involving 2 steps. And now we have a situation where we're going from grams of one substance to grams of another substance. In that case, you're going to need 3 conversion factors in series in order to carry out that calculation. Okay, so before we get to the limiting reactant discussion, let's start off with assignment number 9. So, and if I know that so few students will be coming to class in person, I'll print less copies. And for you guys out there in Zoom, let me go ahead and publish assignment 9. Here. Okay. Okay, so you guys out there in Zoom, you can now download assignment 9, which I'm doing right now. All right, so again, Remember what I said earlier? Make sure to check that all the equations are balanced before you can even start doing the calculation part, right? Okay, so let's hear what you have to say about this problem. Based on what we have done so far. Let me get my pen here. Okay, so the question says, how many grams of sodium sulfate will be formed if you start off with 200 grams of sodium hydroxide? All right, and they gave you the equation, which by the way is balanced already. All right, so you're going to start off with 200 grams of sodium hydroxide, and you're asked to find the amount of sodium sulfate in grams. All right, so we start off with that 200 grams of sodium hydroxide. Okay, so my first question is, what would be the first conversion factor you multiply that by? What would go up here, up top, as numerator, and what would go down here as a denominator? And you can look at the previous examples that we done earlier to help you to do this.
One mole of
1 mole of
sodium hydroxide
1 mole of sodium hydroxide above,
and a mole of mass.
and a molar mass. Now, in the case of sodium hydroxide, molar mass of sodium hydroxide is 22.99 for the sodium plus 1.6 for the oxygen plus 1.008 for the hydrogen. So that's 40.00 grams of sodium hydroxide. All right. Okay, very good. So that this unit will cancel out with that unit. All right. Okay, next conversion factor. What would you multiply that by? What would be up the top here as a numerator, and what would go down here as a denominator?
One would be 2 moles.
2 moles of
Sodium hydroxide.
sodium hydroxide, and what would go up top?
One would go 1 mole sodium
1 mole of
sulfate.
sodium sulfate. Okay, very good. So that this will cancel out with that. So up to this point, we have determined the moles of sodium sulfate. But remember now, the question is asking for the grams of sodium sulfate, which means what? What do we multiply that by in order to get the grams of sodium sulfate in there? What would go top here, and what would go below here as the denominator?
One would be mole of sodium sulfate.
Okay, so how many moles of sodium sulfate?
1.
1 mole of sodium sulfate. And the molar mass, of course, will go up top.
Yeah.
So this time I feel lazy. Let me just do the molar mass calculator here. So Na2SO4. And let's see what that gives. That gives 142.04. So let me write that here. 142.04 grams of Na2SO4. So okay, so that's the setup. This is going to cancel out with that. So now we're going to do the number crunching. 200 divided by 14.00 divided by 2 times 142.04. And according to my calculation, this works out to be equal to, and again, correct me if I'm wrong, but I got 355 grams of sodium sulfate. All right. Any questions about this one? Any questions? Any questions? Questions? Any questions out there in Zoom? All right, let me clear this. Can I clear this? Can I clear it?
Yep.
And or I guess the proper question is, may I clear it? Okay, so let me hear what you have to say about this one. They gave you again the balance equation. Again, make sure that you check, make sure the equation is balanced. And now this question is asking, how many grams of lithium nitrate will be needed to make 255 grams of lithium sulfate, assuming that you have an adequate amount of lead sulfate to do the reaction, right? So basically, if I were to summarize this question, they gave you 255 grams of lithium sulfate, and they're asking for how many grams of lithium nitrate. All right, so start off with 255 grams of lithium sulfate. Okay, and then we multiply that by 1 mole over the molar mass of lithium sulfate. So let me do the lithium sulfate calculation here. Okay, so according to this, the molar mass of lithium sulfate is 109.94 grams of lithium sulfate. And this is 1 mole of lithium sulfate above. Okay, so going back to the problem, what would be the next step? I've done the first step for you. So what's the next step? Now that we have these two canceling out here and here, what do you think the next conversion factor is going to be? What goes up top, what goes below?
Moles of sulfate on bottom.
2 moles of Li2SO4 below.
Or sulfate.
Exactly, 4 moles of lithium nitrate. Okay, very good. So that this goes with that, right? And then the next conversion factor is going to be what?
One mole of lithium nitrate on the bottom,
Mm-hmm.
and then the molar mass on top.
Okay, so let me do that calculation here. So lithium nitrate is what we're trying to find the molar mass of. And according to this here, the answer is 68.95, so that goes here. 68.95 grams of Li-NO3, okay? So that this unit will cancel out with that unit, all right? So again, we have to do the calculation. 255 divided by 109.94 times 4 divided by 2 times 68.95. And according to my calculation, excuse me, the answer rounded out to 3 sig figs is going to be 320 with a decimal point here, and grams of lithium nitrate. And that would be the final answer, right? Okay, any questions about this one? Any questions? Okay, so what I'm gonna have you do right now, can I clear this? All right, let me clear this. Okay, I want you to do questions 3, 4, 5. See how many of these questions there. Oh, quite a lot actually. Okay, so basically questions 3 through I'm sorry, 3 through 11. Now, some of them, the equations are not balanced, right? So check that first before you actually do the math part of the question, all right? And of course, I'm here to help you if you need any help, all right? In the meantime, let's see who came in late. Let's see here. Let me get all of this here. Okay, is Browning here? Browning? Okay, I don't see Browning. Is Cook here? Don't see Cook. Darga? Darga is here. Davis? I don't see Davis. La Fortune here. Cool. Cool. Yeah, don't see cool. Nemi. Is Nemi here?
I'm here.
Oh, Nemi's here, okay. Ortega. Ortega. Okay, I don't see Ortega. Tanan de Jesus is here, okay. And that's it. Okay, Mr. Canon de Jesus, you were saying what? Let me see here. Oh, did you email me yesterday? Because I remember there were a couple of students in your situation and I didn't get a chance to email back to them. Okay. Oh, I did email you. Did I say in the email that I'm going to contact the testing center? Okay, good. I have not a chance to do that yet. So I'm going to do that today. And unfortunately, I wrote down the names of students in your situation, but I left them at a column. But since you just messaged me now, I'll be able to contact them and tell them about you. And I'm going to extend the deadline until this Thursday. I would prefer that you do so, and this is an answer to Aishalin Dakra. I would prefer that you send me an email through Canvas as opposed to the regular college email system. All right. I check that more often in terms of my students compared to the regular college email system. So yes, I prefer that you do that. All right. Okay. I'll be right back.
Hey, Professor. Tristan from the chat says that she's having trouble attaching files for the test 2 assignment.
I'm sorry, repeat that?
Tristan from the chat says that they are having trouble attaching files for the test 2 assignment.
Let me see here. Let me see. Let me see, test two. Oh, okay, I see what the problem is. I forgot to indicate the submission type. Okay, you should now be able to upload stuff.
Thank you.
Mm-hmm. Number 8, okay. Okay, so number 8 says calculate the mass of sulfur that would react with 0.576 moles of copper. So the way I would approach this problem, oops, is I would start off with the 0.576 moles of copper. And then I would look at the mole ratio between the sulfur and the copper. That would be 1 to 1. Oh, first we have to balance the equation, very important. So to balance this, I'm going to need 8 here, and I'm going to need 16 here. All right. And then we have to figure out what I'll put up here and down here. We're looking at the relationship between the copper and the sulfur, right? So in terms of the mole ratio, it's going to be a 16 to 1 mole ratio. So I'm going to put 16 moles of copper below and 1 mole of sulfur 8 above. So this will cancel out with that. And then now to get a mass of sulfur, I need another conversion factor where 1 mole of S8 will be equal to the molar mass of sulfur, which is 32.07 times 8. So that's 256.6 grams of S8. That will cancel out with that, and then we do the calculation. So 0.576 divided by 16 times 256.6. And according to my calculation, rounded off to 3 sig figs, that would be 9.24 grams of S8. That's how I'll do that. All right. Alright, before you guys leave, let me just say, it's here, that, you can go ahead and do all the other questions up to, as I said before, question number 11. I don't want you to start question number 12 yet because that deals with another related topic that we haven't discussed. Also, I want you all to watch the video for the next chapter or videos. It's not a long chapter. Chapter 10, dealing with topics like energy and so on. All right. The main topic is energy. As you can see here, there are 2 links. So make sure you watch those videos because after we complete chapter 9, then we're going to move on to the assignments for chapter 10. All right. So make sure you watch those videos. All right. All right. So that's it for today. And I'll see you guys next Tuesday. And you guys out there in Zoom, I'm going to sign off now.